Hi all, and welcome to the Emergent Vision Technologies presentation. I am John Eilert, President, CTO, and company founder, and I look to provide details of what the next steps are for Emergent as the pioneers of 10 GigE, 25 GigE, and 100 GigE high-performance camera solutions. Some highlights about Emergent are presented here. We are a multi-award winning company with a focus on high-performance GigEVision product. We have many years shipping products at speeds of 10 GigE, 25 GigE, and 100 GigE. We have a strong focus on providing end-to-end technologies and comprehensive support for our customers' applications. Here's a quick snapshot of the adoption of GigEVision products ranging in speeds from 10 GigE up to 100 GigE. Emergent has shown how top performance can be achieved and opened up many markets including machine vision and entertainment to the use of such technologies. Some companies are just now leveraging our efforts towards releasing 25 GigE and higher speed product, but still a ways to go to provide ratified, mature, and performance product. Speeds like 10 GigE, 25 GigE, and 100 GigE are a must-have in many applications. However, as we launch our new Eros 10 GigE line of cameras in 2024, we will be leveraging our deep experience in performance applications to reliably support 10 GigE, 5 GigE, and lower speeds in one or more camera per server applications, with a wide variety of performance processing options in the same zero copy and zero loss sense. With such a broad range of products, we find it helpful to chart out the various resolutions and frame rates provided. At 10 GigE, the products range from 0.5 megapixel at 1500 frames per second up to 50 megapixel at 23 frames per second. At 25 GigE, the products range from 0.5 megapixels at 1600 frames per second up to 127 megapixels at 17 frames per second. And at 100 GigE, the products range from 2 megapixels at 3462 frames per second up to 152 megapixels at 16 frames per second. For line scan, the products range from 4K at 172 kHz line rate up to 16K at 400 kHz, with a special nod to 9K TDI at 600 kHz line rate. As we go to full production with our new Eros 10 GigE line of cameras in Q1 of 2025, we'll introduce many of the same sensors we already support, but now in lower speed, lower cost, and much smaller size options. SWIR is also coming to the Eros product line in the same time frame. As we presented at the recent Vision Show in Germany, we have the Eros camera line operating at 10 GigE speeds now, and for the RJ45 PoE version, the cameras can auto-negotiate to 5 gig, 2.5 gig, and 1 gig for lower speed operations. We do all this in an attractive 29 by 29 millimeter form factor. This is all made possible by the lowest power consumption of all 10 GigE and 5 GigE cameras of all manufacturers in the industry. In fact, the Eros operating at 10 GigE with PoE has lower power consumption than any 5 GigE camera in the industry. And very noteworthy is the feature set is not reduced compared to other models, and Emergent's same reliable and mature zero copy and GPU direct solutions are available for an overall solution that is second to none. While Emergent has been shipping 100 GigE cameras for over 4 years, the sensors, while still very good, were front illuminated. Not only has Sony announced sensors now capable of 100 GigE speeds, but these will also follow their Gen 4 pixel architecture, which is based on backside illuminated sensor technologies, which allow very high quantum efficiencies for greater sensitivities, which is a great benefit when going ultra-high frame rates, where exposures need to be kept shorter. GPixel has also announced a 14 megapixel backside illuminated sensor. Both will be released in Emergent Zenith 100 GigE models in 2025. Firstly, for all those who visited our booth at the recent Vision Show in Germany, a big thank you from the Emergent team. For those who missed us at the Vision Show, we give here a short personal tour. We scaled up our booth substantially and spared no expense to make sure you could see firsthand what gets our customers so excited. We hope to see you all at a trade show near you. In this demo, we had a single server running 3 line-scan 100 GigE cameras showing the use of GigEVision 3.0 RDMA Rocky V2, the fastest demo in the market. In this demo, we had a single Intel desktop server with GPU Direct and machine learning defect detection running 4 25 GigE cameras and 4 10 GigE Eros cameras, which are the smallest and lowest power in the market. In this demo, we had a single server with GPU Direct and real-time reconstruction from 36 10 GigE cameras. In this demo, we had 2 servers and 8 25 GigE cameras showing our FlexProc and FlexTrans technologies, which allows zero-copy movement of data to and from anywhere in the system, which benefits customers who need to distribute processing to other resources when processing bottlenecks appear. In this demo, we had a single NVIDIA Orin IGX server with GPU Direct and real-time fisheye image remapping using 2 100 GigE HZ 65000G 65 megapixel cameras running at 71 frames per second. We are going to take a look at a few case studies now. We will start with Sanovo Technology Group, which is an excellent example of how emergent technology and support can help level up a system both in price and performance. We see the Emergent first aid kit, which is always an indication that a customer has worked with and failed to realize their goals with the top camera manufacturers in the industry. At this point, Sanovo turned to Emergent, having never worked with us before. Sanovo was shy to purchase immediately after being forced to buy and test cameras from other manufacturers for their desired configuration. Shockingly, or maybe not so shockingly, Sanovo was not able to achieve stability with 1/4 of the desired camera quantity. At Emergent, we were so confident we could fulfill their needs that we offered a money-back guarantee on a turnkey system including 21 cameras, server, switch, NICs, GPUs, etc. We used eCapture Pro to prototype the configuration and delivered this to Sanovo, where they promptly approved and then began writing their final application with the Emergent ESDK. The next case study is another excellent example of how Emergent helped level up a system both in price and performance. Norfolk started working with one of the usual top camera manufacturers with their 10 GigE cameras for their multi-camera railcar inspection application. This was the same manufacturer that typically does not test their 10 GigE cameras in more than 2 per server. Predictably, Norfolk had issues with stability in low camera counts. Not only did Emergent Technologies allow Norfolk to meet their initial goals, but also allowed them to surpass their goals by moving to higher frame rates with our 25 GigE Bolt cameras for an overall system performance improvement. One of our longest standing customers is Hawkeye, which is owned by Sony. Another long-standing customer in sports analytics is Kinetrax, which is now also owned by Sony. These are 2 of many Emergent customers who are in the sports analytics field, and the sports are wide-varying and covering all the major sports leagues. 10+ years ago, we were supporting systems of up to 16 10 GigE cameras per server with zero copy and reliable performance. And performance has only grown since then, thanks to the advancements in CPU, memory, and GPU technologies. One of the most interesting applications was developed by Sony Hawkeye in the way of baseball seam tracking, which allows them to determine the spin on the ball and ultimately allows them to determine virtually in real time what type of pitch was thrown. Hawkeye is now working with our Zenith HZ 10000G 100 GigE cameras with a frame rate of up to 1000 at full resolution of 10 megapixels. Smaller high-end laboratory setups make use of our Zenith 100 GigE cameras as well. ARCNL, or the Advanced Research Center for Nanolithography, has successfully used the Emergent Zenith 100 GigE HZ 2000G 2 megapixel camera for experimental interferometric and vibration measurement in DHM, or digital holography microscopy. Small semiconductor wafer fragments were used as part of the experiment. Compact size, GPU Direct, low latency, reliable transfer, and overall performance were key in the selection of the Emergent camera. While Emergent cameras are finding their way into many wind tunnel monitoring systems, one of the highest performance systems is using 16 Zenith HZ 21000 100 GigE cameras, which uses multiple servers and a single 100 GigE switch for PTP and stream routing to the various servers, which house GPU processing resources. Long cable lengths are a big benefit, but very important also is the quality and consistency of the camera product. AOI applications are often striving for higher resolution, and with this must come an acceptable frame rate. One such AOI customer utilized two Zenith 100 GigE HZ65000G 65 megapixel cameras with its top frame rate of 71 frames per second. As always the case, customers rely on either zero copy performance in saving data to disk or the ability to use GPU Direct to get immediate access and real-time processing capabilities to realize maximum performance and throughput in their systems. Of course, all the benefits Emergent brings with area scan cameras are also just as relevant to line scan cameras. With the explosion of electric vehicles on the market comes the need for higher performance inspection of critical components of these vehicles, and here no component is more critical than the battery itself. Emergent is engaged with many customers in this space, and the Pinnacle 100 GigE LZ16KG5 and LZT 9KG5 TDI cameras are a perfect fit. The 16K 400 kHz LZ16KG5 is a great choice to decrease the number of line scan cameras to scan the full foil width, while the 9K 600 kHz TDI LZT 9KG5 camera is a great choice for applications which are more light-starved or which need to run at higher rates without changing the light levels. Of course, Emergent has lower performance line scan camera models where needed. One of Emergent's initial work in volumetric capture was with the Intel Studios group. For their system, we supplied 100 Emergent 25 GigE Bolt 50 megapixel cameras and wrote the capture software and UI front end, which later formed the basis for our current eCapture Pro. We also assisted in switch and server configuration as well as remote troubleshooting to get the system fully functional and stable, a service we provide all of our customers. In parallel, we were working with a significant customer who started working with our 10 GigE cameras, but later, as our Bolt 25 GigE cameras came out with the new Sony Prejudice S sensors, they quickly shifted to these models. The system started with lower camera counts of 100 or so, but later evolved into systems comprised of upwards of 500 25 GigE Bolt cameras in multiple locations. On a side note, this is one customer that heavily relies on multicast technologies, which are not available with RDMA and Rocky V2, nor with CXP. Distributed processing and redundancy are critical factors for many systems, both big and small. It's worth noting that all of the preceding systems have been provided without GigEVision 3 Rocky V2, but rather Emergent's very mature driver technology was employed in ways not unlike the very common filter drivers for GigEVision cameras we've all become accustomed to. The main difference is our drivers are fully zero copy. Any NIC that supports Rocky V2 can also support generalized zero copy needed for GigEVision GVSP. Rocky V2 drivers will all still be proprietary like filter drivers, and some will be better than others. With Rocky V2, it is really only the NIC chip technology that is standardized for our benefit. Despite the limitations of GigEVision 3 Rocky V2, we do have such support with a simple firmware upgrade to our existing cameras, if this is important to our customers. Do note that the standard update is still about a year away from ratification, which at that time will help to keep cameras and third-party softwares more interoperable. Interoperability, incidentally, can also currently be achieved without Rocky V2 through the use of popular GenICam GenTL standard, for which Emergent provides driver support. It also should be noted that Rocky V2 and zero copy is not the silver bullet for performance applications, and this is absolutely no different for those thinking CXP is any better. As long as Emergent has existed, we have focused our attention on maximizing system performance, which did not come overnight, but rather experience was gained and techniques honed over many years. Now, as for the balance of the presentation, we will work to outline what customers can expect as they move to GigEVision 3 Rocky V2. This slide highlights the point about multicast technologies. GigEVision plus GVSP is currently the only protocol which supports this fundamental networking feature. Other standards will be quickly dismissed in applications requiring efficient redundancy and distributed processing. This short animation illustrates how the data from one camera can be sent to multiple devices for parallel processing. A simple use case could even be where a separate system is used for display, while one system performs intense calculations. This slide is an illustration of how the proposed or ratified changes are converging the interface standards. USB remains mostly the same, but is a point-to-point technology. CXP has adopted the Ethernet physical layer, converging towards GigEVision. GigEVision plus RDMA and GigEVision plus TCP, if and when ratified, is converging to CXP and USB as a point-to-point technology. This is perhaps 2 years out. GigEVision plus GVSP will maintain its integrity and feature set and not converge with the other protocols. With the introduction of the use of TCP and RDMA for GigEVision image transmission, we see that for some camera providers, the use of these different protocols is creating a fragmented landscape whereby different NICs and drivers will need to be supported across the industry by various third parties. With top performance, Emergent is able to maintain the current protocol across all speeds of interface and not jump around with different protocols and NICs to support your needs. Why are packet resends used with TCP and RoCE v2, and what are the implications on jitter and latency? If a system is not well designed and tuned, then no amount of resends will allow the system to run in a stable manner and will indeed drop packets and frames. In addition, when image transfer bandwidth is slow due to poor system design, then buffers fill up. The fullness of the buffer is a measure of the system latency. The filling up and draining of the buffer is a measure of the system jitter. Both jitter and latency are important in machine vision systems, especially those needing to make timely decisions, and both are a sign of an unstable system with poor or no safety margin. What we see here are actual tests run with an Emergent 100 GigE HC10000G camera, where we have one oscilloscope channel sampling the exposure signal directly at the camera, and the other channel is sampling a signal from the application, indicating when the image is received and accessible in the host application. We note that with a finely tuned zero-copy system, that there is no buffer backup and no need for crippling resend technologies of TCP and RoCE v2, which are really more appropriate for large file transfers than for real-time machine vision systems. What we see is that RoCE v2 requires more FPGA resources to implement, and as such, the cost of the FPGA will be higher than that of the lightweight standard and mature GigEVision GVSP protocol. This is even more so true if a resend buffer is implemented. We see that in order to create the smallest and lowest cost camera, that these cameras from various manufacturers are not supporting RoCE v2 below 10 GigE, and some not below 25 GigE. This is one way in which Emergent's new Eros 10 GigE offering will continue to provide true zero-copy performance, while the others rely on TCP and conventional GVSP processing, which yields 3 times the memory bandwidth and 33% efficiency of the Emergent zero-copy methods. In multi-camera systems, Emergent will remain unmatched in system density and price performance metrics. And remember that while many state low CPU utilization, that it is actually memory bandwidth utilization that is hiding in the background and preventing maximal system performance. While RoCE v2 can provide a zero-copy solution, there is still a long list of concerns regarding its applicability to machine vision applications, of which proponents will not make you aware of. Which of these are applicable to your particular application can be unique, but we present a fairly exhaustive list for convenience. I will state that all items listed have been noted by our current customer base and have thus decided RoCE v2 is not appropriate for their applications. On the other hand, we have yet to have a customer which we have not satisfied with our solutions, and nobody matches us on performance, support, and price. Since Emergent was founded back in 2007, our focus has been on performance and multi-camera applications, with a strong focus on the big picture, which is developing the highest performance, highest density, lowest cost solutions, and providing processing options which answer the question of what do we do with all that camera data. As you can see, Emergent has the highest performance camera portfolio, and we keep our overall product portfolio focused. We innovate, develop, adapt, and expand the markets we enter, and have the foresight to do so. Please do contact us for further details, and we appreciate you taking the time to view our presentation.